Bismillahirrahmanirrahim. Assalamu alaikum. My dear student, I hope you all are doing well. Welcome to our channel Chemistry Unlocked. Today we will do another video class on hybridization, and it is the stepwise classes. You know it. In the first two classes we have discussed about the basic concept in the lecture 1, and in the lecture 2 we have already discussed sp3, sp2 and sp hybridization. Now in today's lecture we will start sp3d, sp3d2 and sp3d3 hybridization with their bond angle and examples. Okay, now let us start on our lecture. Today first we will discuss sp3d hybridization. So dear student, look at here, sp3d hybridization, it means here one s, 3p and 1d orbital will participate for intermixing process. So 1s and then 3p, 3p means here px, py and pz, px, py and what, pz orbital will intermix together. This is px, py and what, pz, and 1d, and here the d will be dz square, dz square. So here px, py and pz and here is s. Now these 5 orbitals will intermix together to produce 5 number of hybrid orbitals, sp3d hybridization, Now they will produce 5 number of sp3 hybrid orbitals. How they will be arranged together? Trigonal bipyramidal. That is what? Trigonal bipyramidal. 1, 2, 3, 4 and what? 5. Trigonal bipyramidal. Look at here, my dear student, and here the bond angle will be what? These 3 trigonal orbitals will be arranged together to make the bond angle 120 degree, and rest the 2 orbitals which are present perpendicularly will make 90 degree. So their bond angle will be what? 90 degree. So in this hybridization we can say that 2 types of bond angles are present among the hybrid orbitals. So 3 orbitals will be present in this way, 3 orbitals will be present in this way, trigonal shape, and rest of the 2 orbitals will make what? Perpendicular shape, like this. Like this. Look at here, like this. So this triangular shape will make 120 degree, but this perpendicular shape will make what? 90 degree in the upper condition and the lower condition. So the thing is that trigonal bipyramidal will make total 5 orbitals arrangement. Now we will give you an example in this regard. So every orbitals here known as what? sp3d hybrid orbital. So my dear student, again the final touch about the definition or basic concept about this sp3d hybridization. 1s means number 1s orbital, number 3p orbitals and 1d orbitals, that is dz square orbital, will intermix together and they will total number of hybrid orbitals is 5, 1, 2, 3, 4 and 5, 1, 2, 3, 4 and 5. So, and the 3 orbitals will be arranged in this way, like they will arrange like this trigonal shape, and rest of the 2 orbitals will make this perpendicular shape. And bond angle will be 2 types. Trigonal shape will make 120 degree. Again finally I am showing you trigonal shape, this 120 degree, and rest of the 2 orbitals here 90 and here also 90. Now let us talk about the example. Now PCl5, PCl5 you know, phosphorus 15, 1s2, 2s2, 2p6, 3s2, 3p3. So 1s2, 2s2, 2p6, 3s2, 3px, 1, 3py1, 3pz1 and 3d is 0. 3d is 0 at normal state. So at excited state 1s2, 2s2, 2p6 and 3s1, 3px1, 3py1, 3pz1 and 3dz square 1. And the thing is that here total number of orbitals is what? 1s and here 3p and 1d, and they will make what? sp3d hybridization. Okay. Now we will get 5 number of hybrid orbitals like this: 1s2, 2s2, 2p6, psi1, psi2, psi3, psi4, psi5, 1, 1, 1, 1 and 1, and they are known as what? sp3 sp3d hybrid orbital. Now if we draw their structure of PCl5, you know, chlorine, 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 chlorine and what? Chlorine. This is the sigma bonded structure of your PCl5. So if you calculate the steric number, you know that steric number is what? Number of sigma bond, plus number of lone pair electron, number of what? Lone pair electrons. So here how many sigma bonds here? 5, and there is no lone pair. If you observe this electronic configuration, 5 number of unpaired of phosphorus already participate in the 5 sigma bonds. There is no lone pair of phosphorus, so here lone pair is 0 and steric number is 5, and you know that steric number is 5, that is sp3d hybridization, that is already discussed in our first classes. Okay. Now using this formula we can also say that this is sp3d hybridization. So if we use the another formula, you know, that is H equal to half into V plus X minus C plus A. So half V means what? Valency electron. You know that, dear students, here total number of valence electron is 5, 1, 2, 3, 4 and 5. So valency electron is 5 here, and X is what? Number of monovalent atoms. So here in the PCl5 chlorine valence is 1. So 1, 2, 3, 4, 5, there is total monovalent number of atoms of chlorine is 5. So it is 5. this is 0 and this is also 0. Why? Because C is charge on cation, A is for what? Charge on anion. This is not a cation, not an anion, so their value will be 0. So here 10 by 2, that is 5. So again it is sp3d. So by using these two formula, we can easily say that in PCl5 hybridization type is sp3d. You can use any of the formula from this. One is H equal to half into V plus X minus C plus A, and also this static number calculation, which is your easier to use for you. Okay. Now we will draw the diagram. So we will draw the diagram now. So dear students, look at here, PCl5 diagram with hybrid orbitals. Okay. Now already we have drawn this electronic configuration. Just I am recalling this final structure. I am recalling just the final structure. Okay. Now now 5 hybrid orbitals will be produced in case of phosphorus. So this is what? 3s1, 3s1, 3s1 having a single electron, 3px, 3py and 3pz, 3px, 3py and what? 3pz single electrons. And now what? 3dz square single electrons, 3dz square. Now 3dz square, 3px1, 3py1, 3pz1 and 3s1, and they will make what? sp3d hybridization process. Now we will get 5 number of sp3 hybrid orbitals, 1, 2 and 3. This the nucleus of your phosphorus atom. Now 1 electron and 1. This is the trigonal shape arrangement of the 3 hybrid orbitals, and this is the perpendicular shape of the rest 2 orbitals. Okay. Now their bond angle is what? 120 degree and what? 90 degree. So one is 90 degree, another is what? 120 degree. Okay. Now bond formation. Now the bond formation. Okay. I think you can understand this. Now the bond formation. Now the bond formation. Okay. Bond formation. Now bond formation. So phosphorus 1, 2 and what? 3. Trigonal shape. Trigonal shape of phosphorus, 3 hybrid orbitals having the unpaired electron, and similarly the 2 hybrid orbitals perpendicularly, and these 2 unpaired becomes what? Every this unpaired electrons becomes paired with what? The unpaired of chlorine. Unpaired of what? Chlorine. Like this. Unpaired of chlorine. Unpaired of what? Chlorine. Like this. Chlorine. Chlorine. So my dear student, look at here. This is the trigonal bipyramidal shape of your what? PCl5 structure. So, here bond angle is chlorine, phosphorus, and chlorine is what 120 degree, and another is what chlorine, phosphorus, and chlorine is what 90 degree. So, these three orbitals makes what 120 degree, but this makes what 90 degree. Okay. So, this is 90 degree and this is what 120 degree. I think you understand this. So, here bond angles are two types 120 and 90, and these are what sp3d hybrid orbitals. And the thing is that here head to head overlapping. So, this is sigma bond, this is sigma, this is sigma, this is sigma, and this is also what sigma. And you can also write here sigma is formed between the sp3d and what, this is the p orbital. So, sp3d and p orbitals. So, this is the hybrid and this is what non-hybrid p orbitals head to head overlapping can make what sigma bond. So, my dear student, this is the structure of your PCl5 having the hybridization type sp3d. Now, let us talk about the next type hybridization sp3d2. 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 So, in this type we can see that here one is 3p, 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 3p and 2d dz square, and what dx square minus y square, dx square minus y square. Dx square minus y square. So, here how many orbitals are participated? Total is here s, here px, py, pz, dz square and dx square minus y square, that means 1 and 3, 4, 5 and 6. So, we will sp3d2. So, we will get 3, 1, 4 and then do 6. Total number of orbitals, hybrid orbitals will be what 6. And what will be their arrangement? 6. Look at here, my dear student, square bipyramidal shape. 1, 2, 3 and 4. This is the square shape. Now, bipyramidal, one is perpendicular, another is another perpendicular shape. So, here bond angle will be what 90. All bond angle will be what 90. So, here bond angle is what 90. Why 90? Now, look at here. Here the shape will be what square bipyramidal. So, like this square shape, okay. This is square shape. So, square shape here bond angle is what 90, here 90 and here also what 90. Okay. How 90? For example, it is a straight line and now here is a crossing. So, it is 90 and here another crossing. So, it will be what 90 and this bond angle is 90 and perpendicularly another orbitals is here also 90. So, here all these bond angles are 90 and perpendicularly is 90 and here also another perpendicular orbital is also 90. So, all these bond angle here make 90 degree. Okay. So, this is the sp3d2 hybrid orbitals, and all these sp3 hybrid orbitals arranged together in a shape square bipyramidal. So, this is what square bipyramidal, but bond angle is what 90 degree. Now, let us talk about the example. Okay. Example of this hybridization type is SF6. SF6. You know, in SF6, 1, 2, 3, 4, 5, 6. Total number of fluorine is 6 here. Okay. So now hybridization type you can find out here easily. You know, the electronic configuration of sulfur is this: sulfur 1s2, 2s2, 2p6, 3s2, 3p4. Okay, and here 3d is at normal state 0. Now if we make it excited, 3px, 3py, 3pz. So it will be 2, 1 and 1. So 3d is also 0 at normal state. Okay. Now at double excited condition, then 1s2, 2s2, 2p6, 3s1, 3px1, 3py1, 3pz1, 3d z square 1 and 3d x square minus y square 1. So here total number of hybrid orbitals will be 6, 1, 2, 3, 4, 5 and 6. All these orbitals will participate in sp3d2 hybridization process. sp3d2 hybridization process. Okay. Now the total number of hybrid orbitals will be psi 1, psi 2, psi 3, psi 4, psi 5 and psi 6. Okay. Now let us talk about the finding. Again, steric number, you know, number of sigma bond plus number of what? Lone pair. Okay. So sigma bond is here 6, lone pair is 0, 6 is what? sp3d2, and another formula is H equal to half into V plus X minus C plus A. So here number of valence electrons is what? 6. Number of valence is 6 plus number of monovalent atom is 6 minus 0 plus 0, that is total collection will be 6, and here it will be sp3d2. So from this calculation, you can easily find out that here sulfur atom of this SF6 will show sp3d2 hybridization. Now let us talk about the diagram. I think so you can understand about the finding. Again, in the SF6, number of sigma bond is 6, number of lone pair is 0 in case of sulfur. So it is 6, and 6 means what? Steric number sp3d2 hybridization, and here valence electron is 6, and you can understand this diagram. And here number of monovalent atom is also 6, and here it is 0 because this is not cation or not anion, so these are also 0. And finally we will get the result of H is 6, and 6 means what? sp3d2 hybridization. Now let us talk about the diagram. Now in case of SF6, the diagram will be final diagram. Already we have seen that 6 number of hybrid orbitals. Okay. So 6 number of hybrid orbitals will be produced in the valency shell of sulfur, 1, 2, 3, 4, and their arrangement is what? Their arrangement is what? Square shape. Okay. So square shape is like this, and their arrangement will make the bond angle 90 degree, and also here 90, and here also what? 90, and here the atom will be what? Sulfur, and having the unpaired electron in each hybrid orbitals, and the fluorine atom having the unpaired electron of the p orbitals will be head to head overlapped, and here also head to head overlapped, here head to head overlapped, and here also head to head overlapped, here also head to head overlapped. So this is that fluorine, and here also a head to head overlapped, and here also head to head overlapped, and here also a head to head overlapped. So here sigma, 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 and this is what square bipyramidal structure of SF6 having the bond angle 90 degree. So, we can write here fluorine, sulfur, fluorine is what 90 degree. I think my dear students, you have understood this diagram of sp3d2 hybridization. Now, the another structure of sp3d3. Now, the last here sp3d3 is, you know, one is and 3p, px, py and what pz, px, py and what pz, and d3, dxy. Okay, dear student, you may have the question which d will participate in the hybridization, sp3d y dz square and y in the sp3d2 dx square minus y square and dz square, but y in this sp3d3 dxy, yz and zx. I will make it clear in the upcoming lectures, but now we have to know these types of hybrid pure atomic orbitals will participate in hybridization process, but because this explanation needs another explanation why they are participated here. Okay. So, now dxy, dyz, dyz, dyz and dzx, dzx. dxy, yz and dzx. Now, I will make you some explanation about this. Okay. Actually, d orbitals are two types. One is EG set orbitals and T2G set orbital, and these orbitals are T2G set. Actually, d orbitals are what two types? One is EG set orbital and this one T2G set orbital. EG orbitals are dz square and dx square minus y square, and here dxy, yz, dzx. These are the what T2G orbitals, and the main property of these two set of orbitals is their lobes. LOBES, lobes will be present in case of EG set orbitals along the axis, that means through the axis. For example, dz square we have drawn like these types of structure along the axis, this is the dz square, and also dx square minus y square along the axis of x and y axis. Okay, these are the EG set orbital, but these are the T2G set orbitals. Look at here, my dear student, these are the what T2G set orbitals, and these orbitals lobes are always present in between the axis. Again, I am telling you, not through the axis, not along the axis, in between the axis. That means between x and y axis, the two lobes double dumbbell shape. We know that the basic diagram of a d orbital is double dumbbell, that means two dumbbell. Okay. Now, these two dumbbells will be present as the lobes in between the two axes x and y, that is known as what xy. When y and z, that is dyz. When in between z and x, that is what zx. You may ask you the question that how it is y and how it is z. Actually, all these axes x and y are present to each other perpendicularly, making the 90 degree bond angle. Okay. So, it is, if it is written y or if it is written z or if it is here x, it is immaterial because x and z, two axes are present to each other, making the bond angle 90 degree. Similarly, z and x, similarly y and z, so their bond angle is what, 90 degree. Okay. Now, these are the basic concept about this. D orbitals are two types, EG and T2G set orbitals, and EG set orbitals are orbitals lobes are present along the axis and here in between the axis. Okay. Now, if these orbitals, pure atomic orbitals, intermix together and their hybridization type will be what, sp3, sp3d3. So, total bond angle will be total hybrid orbital number will be 7. Okay. Now, how these 7 will be arranged together? Look at here. 7 hybrid orbitals will be arranged 1, 2, 3, 4, 5. So, this is the pentagonal shape, right? Pentagonal shape. And one is perpendicular, another is what? Perpendicular. So, here total bond angle in the pentagonal shape is 72 degree, because if we divide 360 divided by 5, that is what, 72. So, if 360 is divided by 5, that is what, 72 degree. So, this bond angle is what, 72 degree, but which is present in the perpendicular structure. In the perpendicular structure, this is the perpendicular structure. So, this bond angle will be what, 90 degree. So, my dear student, try to understand here the hybrid orbitals which are present in the pentagonal shape. In the what shape? Pentagonal shape, like this and like this, they are making what, 72 degree. Look at here again, this is what, 72 degree, and this is what, 72 degree, this is what, 72 degree, but which are remain in the perpendicular shape, they are what, 90 degree. So, 5 hybrid orbitals, look at here, 5 hybrid orbitals are present. It is very difficult, like this. Okay. So, here look at here, my dear student. So, this is 1, 2, 3, 4 and what, 5. So, this is the pentagonal arrangement. It is very difficult to take these 5 markers in one hand. So, this is the 5 pentagonal 5 arrangement, 5 orbitals arrangement in one plane. In one plane there are 5 orbitals are arranged, and this 360 divided by 5. That is why every bond angle here 72 and rest is what, 90, here 90 and also here also 90. Okay. Now, dear students, this is the definition or basic diagram of sp3d hybridization. Now, we will make a example. We will make a what? Example. IF7, iodine heptafluoride. Okay. So, iodine, you know, atomic number is 53. So, it is what? Ten, 12, 16, 18, 20, 30, 36, then 36, 10, 10 to 18, 20, 30, 36, 38, 48, then what? 53. Okay. Now, here 5D is present. Okay, 5D is in the 0 condition. Okay. Now, we will just arrange here the last orbit 5s2, 5p5 and what 5d0. Now, you know here 5d xy in the excited condition will 5s2, 5px, 5py, 5pz, 2 to 1. Now, xy, yz and zx. So, if we excite it first time, then 1 will be shifted here, then second time it will be shifted here, then third time it will be shifted here. Now, here iodine will be excited 3 times, right? Okay, this is iodine 53. Now, total orbitals here 7. So, here will be sp3d3 hybridization and we will get the total number of hybrid orbitals psi1, psi2, psi3, 4, 5, 6 and what 7. 1, 1, 1, 1, 1 and 1. These are what sp3d3 hybrid orbitals. Hybrid orbitals. Now, dear student, let us talk about the finding iodine 1, 2, 3, 4, 5, 6 and what 7. Okay, 1, 2, 3, 4, 5, 6 and what 7. Okay. Now, if we find out the steric number, sigma bond is 7 and 0 lone pair, 7 is what sp3d3. Now, if we use the another formula, H equal to valence electron is what 7, number of monovalent atom is what 7, minus 0 plus 0, that is what again 7, means what sp3d3. So, it is confirmed that in this molecule sp3d hybridization is present. Look at my dear students, from this structure we can find out the type of hybridization. In the IF7 iodine heptafluoride is sp3d3 hybridization. Now, let us talk about the diagram. Okay. Now, the diagram, you know that 7 hybrid orbitals and they will be arranged like this: 1, 2, 3, 4, 5. This is the pentagonal shape. So, this pentagonal shape bond angle is what 72 degree, because 360 divided by 5. So, their bond angle is what 72 degree. Now, this is iodine and here rest of the 2 hybrid orbitals will remain as what perpendicularly, and here every hybrid orbitals will contain a single electron and they becomes paired through head to head overlapping with what fluorine, like this, fluorine, like this, fluorine. Okay, fluorine, fluorine, sigma bond, this is sigma bond, and this is what sigma bond. Okay. So, there are 2 types of bond angle here, one is 72 and another is what here 90 degree. Okay. So, this is what 90 degree. So, this perpendicular structure will make what 90 degree. So, here we can write if is 90 degree, another is if is what 72 degree. I think you are clear about this diagram. So, this is what pentagonal bipyramidal. What is the shape here? Pentagonal bipyramidal. Okay. So, dear student, this is your example of sp3d3 hybridization of IF7. Now, finally, we will just talk about the percentage of hybrid orbitals present in each type of hybridization. Now, let us talk about that. In our next video, we will discuss the shape change or bond angle change of the hybridization. Okay. So in our next video we will discuss about the change of bond angle. Now the last topic for 2 or 3 minutes, look at here my dear students, that is sp3 hybridization. What is the percentage of S? It's a very good MCQ question or short question, or percentage of what? P orbitals. Okay, percentage of what? S, P, then percentage of what? D. Okay, so here in this sp3 hybrid orbitals there is no D. Total number of orbital is 4, 1 S and what? 3 P. So what will be the percentage? So 1 S and what? Total is 3 S P. So here S number of orbital is 1, so 1 by 4, and in percentage it will be what? That is 1 by 4, that is 100, that is what? 25%. Similarly, in case of p orbitals, we can find out here 3 number of p out of what? 1 plus 3 and what? Here 100, that is what? 75%. So very simple question here. In the sp3 hybridization, S percentage is what? 25% and P percentage is what? 75%. Now it is not required to memorize the percentage. It can be easily calculated through these types of method. Now another example for sp2. Okay, so here in sp2, 1 is S and number of P is 2. So for percentage of S, here S is 1 and here is the 100% multiplication. Then what will be produced here? 1/3 and here 100%. Okay, so what will be the result? If we divide it, look at here my dear student, 100 divided by 3. So it will produce 33.33%. Okay, 33.33%. And if we make the percentage of P, so you have 2 divided by 1 plus 2 into 100%, or you can minus from 100%, both are correct, no problem. So here 2 by 3 into what? 100%. So it will be it will make the result 2 into 100 divided by 3. So 66.67%, 66.67%, or you can minus this 33 from 100%. Okay, so in this sp2, percentage of S is what? 33.33 and here P percentage is what? 66.7. Similarly, you can easily find out the others. Now one example for with d orbitals. With d orbitals, for example, sp3d. Okay. Now here percentage of S percentage will be S is 1 and here S is 1 total, P is 3, D is 1 into 100. So what will be the result? 3 plus 2 5, 1 by 5 into 100%. Now here in case of P, P is here 3, 1 plus 3 plus 1, that is what? 100%. Now we will do calculate, that is 3 by what? 5. 3 by 5 into what? 100%. Now finally for D calculation, D is what? 1 and here 1 plus 3 plus 1 into what? 100%. Now do the calculation my dear student. So here 100 divided by 5, that is 20%, and here 100. So here result will be 100 divided by 5, that is 20 into 3, that is 60%, and here 1 by 5 into what? 100, that is what? Again 20%. Now look at here my dear student, S is what? 20%, P is what? 60%, D is what? 20%. The total is what? 100%. Now another thing is that here, another technique, here S is 1, P is 1. Here S is 1 and P is 1. So, the percentage of S and percentage of D will be similar like this. Okay. I think you can understood this calculation of percentage of hybrid orbitals calculation. In this technique, you can easily find out the percentage of hybrid orbitals. Okay. Percentage of s orbital or percentage of p orbitals, or that means pure atomic orbitals that is present in the hybrid orbitals. Okay. So, sp3d hybrid means what? This is made by one is 3 number of pure atomic and d is another pure atomic, s is another pure atomic. Now, what is the percentage in this hybrid orbitals, and that can be calculated in this way. I think it will be very much helpful for your solving the short questions and MCQ, inshallah. So, inshallah, in our next video we will start to describe in details about the bond angles of same hybridization, different bond angles. For example, different bond angles in water, ammonia molecule, methane, though their hybridization is what same. So, there is some reasons we can explain using the Vespers theory and electronegativity effect on that molecule present of different atoms present in that different atoms. So, we will discuss later inshallah in the upcoming lecture. So, wait for that and stay safe and happy all the time, and keep in touch in our channel Chemistry Unlocked. Assalamu alaikum.